Greetings, everybody. I thought I would go through how to balance in basic solution. And so let me show you how to do this. It's very straightforward. What we're going to do to balance in basic solution is we're actually going to follow pretty much the same procedure as balancing an acidic solution, and we're going to have one additional step at the very end. So I'm just going to write that up here for you. Again, you're going to do this, you are going to balance an acidic solution, and there's just one additional step. One additional step at the very end. And that's pretty much it. So let me show you how we do this. Again, so let's, as always, if we're going to balance a redox reaction, split it into its half reactions. Let's do that now. So we've got, and again, you don't have to worry about who's oxidized, who's reduced. It's just who obviously goes together. And I think it's pretty clear who belongs to the CrO4. It's a little rich. So the CrO4, 2-, we know that's going to get to go with who it looks like, its corresponding partner, which is that guy, and of course our sulfide and the elemental sulfur will go together. All right, so as always, we're going to balance for elements first, meaning that we're going to start with everyone but oxygens and hydrogens. So looking at the top half reaction, chromium, there's one on the left, one on the right, it's balanced. Let's look at the bottom half reaction. Again, everyone but oxygens and hydrogens, so left and right, we're good to go. Notice one sulfur, one sulfur. So now let's move on back to our top half reaction. Notice that we have a total of 4 oxygens, but only 2 on the left. So we use waters to balance for oxygens. And so if I've got 4 oxygens on the left and only 2 on the right, I'm going to go into my right side over here, and I'm actually going to balance that. I'll use purple right now because I'm on a purple kick. So that's going to be plus 2 H2Os. We need 2 H2Os because each water has a single oxygen, and we need 2 of them in total. Oxygens are now balanced in the top reaction and the bottom reaction. Let's move on to balancing for hydrogens. So this is where we have to remember, in acidic solution, what did that even mean? In acidic solution, balancing for hydrogens just translated to, balancing for in acidic solution mean adding H pluses, right? That's what that means. So what we're going to do is come in here and we're going to add H pluses to be sure to balance. So that's 4. We've got 4 of those guys on the left side, on the right side. So I'm going to come in over here now and go, okay, I just need plus 4 H pluses over here. That seems to be good to go. And the bottom reaction is already balanced for elements. So hopefully at this point you can now see that we're looking pretty good right now. We are now officially balanced for elements. Let's now balance for charge. Notice that on the left side, let's go through and add all of our charges together. So we've got 4 times plus 1, which is plus 4. Let's see here, 1 times minus 2, so that's just minus 2. And we need that sum, so plus 4 minus 2 is plus 2 overall. So we've got plus 2 overall on the left side. And then up here we've got just a minus 1 plus 2 times 0, which is just 0. So we've got a minus 1 overall on the right side, but we've got a plus 2 on the left side. So you've guessed it, we need to add 3 electrons, because again, I need to add 3 negative 1s, and I need to add those 3 electrons to the drum roll. We've got to make sure that we add those 3 electrons to the reactant side there to bring that down. So if you did everything right, that should be now a balanced half reaction. Likewise, if we look at the bottom reaction, that one's very straightforward. We've got a minus 2 hanging around. So that's a minus 2 there, and we've got a 0 there. So we need to add 2 negative 1s, 2 electrons. And so that's going to go, obviously, on our product side. And looks something like that. We've got to deal with a big problem. I'm sure you can see it. So it's time to add the 2 reactions together. As you can see, before we get to add them, we need to just make sure that that 2 there cancels with that 3 there. And they don't, right? Because they need to be the same number. So least common multiple would be 6. So we're going to multiply everything in the top equation. We're going to multiply everything in that top equation. I'm kind of running out of room on that. Everything gets multiplied by 2. And then here in the bottom equation, everything here gets multiplied by 3. So what does that mean? You're going to distribute that 2, if you want to think of it that way, mathematically speaking, to everyone in the top equation and the 3 through everyone in the bottom equation. If you did it right, then the electron should cancel. Here we go. So again, I'm going to start with that top equation, and it's going to be 2 times 3 electrons, which is 6 electrons, plus 2 times 4 H pluses, so that's 8 H pluses. 2 times 1 chromates, which is just 2 chromates. We have to add all of our reactant side together, so we'll move to the bottom reaction. We have 3 times 1 sulfide, so that's just 3 sulfides. And now we get to go back to the top equation and add all of the products together. So notice we're multiplying by 2 in the top equation, so that's 2 times the CrO2 minus. And I apparently did not listen to my self-talk, so let's just rewrite that one more time. So again, 2 times 1 is just 2, so that's 2 CrO2 minus. And then we have 2 times 4 waters. So that would be plus 4 waters. Plus 3 times 1 sulfide, so that's just 3 sulfides. That's technically sulfurs. And then 3 times 2 electrons, which is again 6 electrons, what we were going for. Notice the electrons are going to cancel, which is what we fundamentally want, which is so exciting. So here we go. So the electrons are now gone. Anything else cancels, and just kind of looking through this, I don't see anything else that's going to cancel. And so now let's write, all right, so this is now a balanced reaction, but remember what we've done is balance this reaction in acidic solution, okay? So I really, really, really want y'all to make that connection that in acidic solution, so going way back up to here, remember what does that even mean? That means that what we just did is we added those H pluses and great. But basic, let's go back up to here. But what does basic even mean, okay? Basic means that we are going to be, that it just means the hydroxide ions should be used to be balanced. So here's the trick. You balance in acidic, just like we just did. And now what we're going to do is we are going to add however many H pluses there are, we're going to add that same number of hydroxides to both sides of the equation. Remember that this guy here is balanced. So whatever we do to one side, we need to do to the other to ensure that we don't affect or undo all of that hard work we just did. So we're going to add, again, how do I do it? I'm going to look at the number of H pluses that I have. I have 8 of them, so I'm going to add 8 hydroxides. Why? What does that do? Well, I want y'all to remember, and this is so important that we can recall this, and that is the following. I'm running out of room here, so why don't I go to a new thing. So I'll just show this to y'all real quick. So remember that an H plus, whenever it meets an hydroxide, it forms water. This is always fundamentally true. So this is a neutralization, as we call it. So then going back to our previous slide, here we go. Let's go through. So 8 waters and 8 hydroxides make a total of 8 waters there. We have plus, let me scroll up here. We now have plus. We didn't change any of our chromates. We didn't change any of our sulfides. We do now have 2 CrO2 minuses, 4 H2Os, 3 sulfurs, and then don't forget what we just added to both sides, the 8 hydroxides. So this is now pretty much done, but hopefully you can see we do have to do one final reduction because hopefully you can see it. We've got eight waters there and we have 4 there, which means waters are on both sides. We can cancel some people out. So I can cancel 4 of those with 4 of those, leaving 4 remaining. And so students, we now have our final. We have 4 H2O. I'll tell you what, I better use this other pen here. We have 4 H2O plus 2 chromate plus 3 sulfides, forming 2 CrO2 minuses plus 3 sulfurs, then plus 8 hydroxides. And students, this is it. This is now balanced in basic solution. So what's the big deal? How is this different than acidic? You balance in acidic first, just like we did, and then you're going to go through and add however many H pluses you have. That's the same number of hydroxides that you're going to add to both sides of the equation. So this final step is really the big difference between balancing in acidic and basic solutions. Adios, amigos.